In this video, we're going to do some problem solving to find linear equations using our prior knowledge. Once again, these equations that we're going to be finding are from questions that don't provide us a lot of context, but do make you really think about what the line actually looks like and what information you're looking for. The question we'll look at asks us to find the x and the y-intercepts of a line that is perpendicular to y equals 9 over 8x plus 1 and passes through the point 18, negative 8. While it's not necessary, I think it's important for you to try to visualize what you're dealing with. So in this case, because we're dealing with an equation in slope y-intercept form, we should be able to graph this line, this original line, very easily. When in slope y-intercept form, we start with our initial value, which we can see our y-intercept is 1. And from there, we'll use our slope, which is a rise of 9 and a run of 8, in order to find other points. Since we're rising 9, we'll begin at the y-intercept, and we will go up 9 units, and we will go to the right 8 units to get our point of 8, 10. Although you only need 2 points to graph a line, it's always nice to have a couple to work with so that you can be as accurate as possible. So, thinking the same logic as we've done previously, we're now going to fall 9 from this point and run to the left 8 to get our third point here. And you'll see the same logic. I'm rising 9, running 8, and I'm using the same pattern. And therefore, we have our original line, and we can now look at our next piece of information is that our new line actually passes through the point 18, negative 8. So that puts us way off our graph here at wherever 18 is. So we'll approximate, and we'll be going down to negative 8 to plot that point. So our new line will actually pass through the point 18, negative 8, and we also know that it's perpendicular to the original line, which means that our line's going to look something like this. So while this gives us a visual, we still need to perform some algebra in order to find the actual x and y intercepts. And before doing so, it would be wise for us to actually find the equation. Here we can see that our x-intercept is going to be somewhere around 10 or 11, and our y-intercept is going to be somewhere around 9, but we can't be certain until we actually find the equation and then find the x and y intercepts. So let's go ahead and do that. Using our knowledge of perpendicular lines, we know that the slope of a perpendicular line is the negative reciprocal of the slope of the other line. So in this case, the original line has a slope of 9 over 8. That means the perpendicular line, or sometimes we annotate it as m perp, is negative 8 over 9. Knowing this about our slope, we can then sub the slope into y equals mx plus b for m, and then we can work to find b, which is the y-intercept, noting that we can see from our sketch that it's going to be somewhere around 9 on the y-axis. So now that we've got a foundation to work with here, we've got y equals negative 8 over 9x plus b, we can then use our knowledge that this line goes through the point 18, negative 8, and substitute 18 in for x, and then follow through by substituting in negative 8 for y, since we do know that that point is in fact on the same line. So after substituting in, we can see negative 8 is equal to negative 8 over 9 times 18 plus our y-intercept. So we can now isolate and solve for b. Now doing some quick mental math here, rather than turning this into a decimal, we note that in BEDMAS we can reverse division and multiplication. It really doesn't matter which goes first. So whether I choose to divide these two, or multiply those two, or even divide these two, it's really up to you. So I'm going to choose to go ahead and divide 18 by 9, because 18 is over 1, and I'll end up with 2. So I have, so I'll have negative 8 times 2, rather than 18 divided by 9, and that gives us the following. Doing a little more mental, we end up with negative 8 times 2, which is negative 16, and we can then isolate for b. Adding 16 to both sides, we end up with a y-intercept of 8. That means the point 0, 8 must be on our line, similarly to the point 18, negative 8. And if we look at our sketch, my line once again was a complete approximation, simply eyeballing that this was perpendicular. So obviously that's not the case, and my y-intercept actually should be here. So that's why it's important for us to be able to do this algebra, because that's my actual y-intercept telling me that this line isn't accurate. So there's a better representation of our new line, which is perpendicular to the original, and thus our new equation is y equals negative 8 over 9x plus 8, and you would hope that you're done the problem, but actually it does say find the x and the y-intercepts of this new line. So we are not done yet. However, we do know part of our solution because we do have our y-intercept. That's what we've solved down here, and we can also see that it's on the graph right here. So we have done our y-intercept, but in order to find our x-intercept, we're going to have to either predict by looking at our graph, or try to find the actual value by using algebra. So that's what we'll do now. So to the left here, we'll find the x-intercept, and noting that the x-intercept is somewhere in this area, the only thing we know about it is that the value of y is 0 for any x-intercept, because it will always be on the x-axis. Your value of y is always going to be 0. Over here, you'll notice similarly for your y-intercept, the x value is always equal to 0. So in order for us to find the x-intercept, we're going to sub in y is equal to 0 into our new equation. So here's our equation. We're going to sub that in for y, and we get 0 is equal to negative 8 over 9x plus 8. And then we can solve for your y-intercept. In this case, I've chosen to take the y-intercept and flip it to the other side by subtracting 8 on both sides. And now I need to isolate x by getting rid of this negative 8 over 9. I could do it in 2 steps, or I can do it all in once. I'll do it one at a time, noting that we have division here, a division of 9, so I'm going to use the opposite operation of multiplication. So I'm going to multiply both sides by 9. And we're left with negative 72 is equal to negative 8x. And then finally, we'll solve by dividing out negative 8 on both sides, and we'll end up with a total of x is equal to 9. So we know our x-intercept must be 9, 0, which is actually here, telling us that, you know what? Where I plotted this point was clearly inaccurate, and we know that our y-intercept is plus 8. There it is there, and we have finally successfully solved this very, very long problem. Having yourself a therefore sentence at the end is probably a good idea to make sure that you explain what you've done.